Good morning, everyone. So, in the last classes, for almost a month, we have seen the fundamentals of solar energy, how the energy is produced in the sun, inside the sun, how it is getting transmitted onto the surface of the earth, and what are the characteristics of the solar electromagnetic radiation, and how to measure the solar radiation falls on the surface of the earth, and various collection techniques, various ways of utilization of solar energy, solar thermal and solar photovoltaic. And we have classified the collectors into flat plate collector and concentrating type collectors. And in the concentrating type collectors, we have seen the classification like point concentrators and line concentrators. Today, we are going to see the new topic, the applications of solar thermal energy. First, we will see the application of solar thermal energy, solar thermal systems. Then, later on, we will be discussing on solar photovoltaic conversion, that is direct energy conversion method. So, today's topic of discussion is applications of solar thermal energy. So, as you are aware, solar thermal form of energy is utilizing the heat or thermal component of solar radiation, which needs to be collected using an appropriate collector, either flat plate or concentrating type collector, and to trap the collected energy using the principle known as greenhouse effect, GHE, and suitably transferring that collected energy to a working fluid, which could be water, more common, or air, or any other low boiling point fluids, depending on the application. So these are the major areas of application of solar thermal energy. Mainly, solar thermal energy is used as such for water heating. You might have seen in many places the solar water heaters, different types of solar water heaters. Space heating, especially this is applicable for cold countries where the house or the closed space is to be heated for the comfort living. Then drying of spices using an air heater. Solar air heater could be used to dry the spice naturally. Then fourth major area is to generate power, undergoing the limitations of second law of thermodynamics. First, the heat will be transferred to a fluid to convert the fluid from liquid form to vapor form. Then that vapor will be utilized in the power generation in a Rankine or Brayton cycle or Stirling cycle. Then water desalination to convert impure water to potable water. This is especially applicable in places where the availability of pure water, drinking water, is scarce. Then cooking, solar cooking in places where electricity or the natural gas or LPG availability are less in rural areas. Then solar refrigeration, not only for heating, solar energy can also be used for cooling purpose. We will see all these in detail, some of these in detail and others just a glance over it. Now, today we will see what are the different types of solar water heating systems. Solar water heaters, these are the features or simple description of solar water heaters. Direct application of solar thermal energy in heating. directly the thermal component of the solar radiation is used, that is for heating. It is not converted to some other forms. Directly that heat or thermal component of solar energy is used in heating water. Water is not converted to vapor, but the maximum temperature will be limited to 100 degrees Celsius. Greenhouse effect is employed to trap the solar radiation. As I pointed out earlier, if you want to collect the energy, there should be a transparent medium layer of glass or two. A single layer or double layer of glass is employed. Then there will be an absorbent surface at which it will be absorbed. Then it will be transferred to the working fluid. So both flat plate or evacuated tube collectors could be employed for heating the water. Hot water is either used for domestic or industrial purposes. This hot water could be used for. So the hot water, heated water using solar energy, could be used for domestic or for commercial or industrial purposes. Both the ways solar water heaters are useful, because the large amount of electricity bill is reduced by the use of solar water heaters. So these are the types of solar hot water heaters commonly employed all over the world. These are the important types: Thermosiphon systems, direct circulation systems, drain down systems, indirect water heating systems, and air systems. So thermosiphon water heater system, I have already discussed in the previous classes. I have shown the diagram. What is the meaning of thermosiphon? Anyhow, we'll explain once again with the diagram in detail these systems one by one. Okay? So thermosiphon systems usually heat water or an antifreeze fluid such as glycol. So this antifreeze fluid and all are applicable only in the cold countries, not for us, where the temperature is pretty low. Otherwise, what will happen? The fluid inside the tubes of the water heater will get frozen. So some antifreeze will be added in cold countries in order to avoid that freezing and breaking of the systems, pipes. So in the thermosiphon system, the important point to be noted is the fluid rises by natural convection, which is a form of heat transfer from collectors. So as the water gets heated in the collector, naturally it will rise up because of the density difference. The hot water is having a lower density compared to cold water, so automatically it gets risen up. That phenomenon is known as thermosiphon action. So fluid rises by natural convection from collectors to the storage tank. So obviously the storage tank is usually placed at the higher level than the collector. So there is no requirement of any pump. So naturally the hot water is risen up, the circulation is maintained naturally by the thermosiphoning action. So fluid movement and therefore the heat transfer increases with the temperature. So these systems are most efficient in areas with high levels of solar radiation. So wherever higher levels of solar radiation is available, these thermosiphon systems are mostly effective, and it will convert thermal component of solar radiation into hot water efficiently. I will show you the diagram. We can see here it is installed on a rooftop. There is a flat plate collector. Here a flat plate collector is shown in this diagram. It can be some kind of evacuated tube collectors also. So there will be a storage tank into which the blue line shows the cold water line and the red line shows the hot water line. Okay. So there is cold water in on the right hand side. You can see cold water in, the blue line on the right hand side at the bottom of the tank, and the hot water out from the top. Because of the density difference, hot water always will be on the top. So the outlet is taken from the top of the tank. Inlet is at the bottom of the tank. Cold water is in, and from the left hand side of the tank, cold water is exiting the tank to the collector. And as the heat is absorbed by the collector, the water temperature increases and it rises in the tubes inside the collector, and due to thermosiphon action, and it will leave the collector through that red line. You can see on the left hand side the red line. It will go back, the hot water will go back to the storage tank. So the storage tank will be properly insulated in order to avoid any heat losses overnight, because there is no availability of solar energy overnight. So the storage tank should be properly insulated in order to avoid any heat losses, so that we can get hot water 24/7. Clear? This is the simplest solar water heater known as thermosiphon water heater. Second system in solar water heaters is direct circulation system, where there is a requirement of pump. So this pump water, these systems pump water from storage to the collectors. So there is a storage tank, collector, everything is same except the addition of this circulating pump. So pump will be pumping or pressurizing the water from the storage tank to the collector during sunny hours. Whenever there is sunlight, the pump will be circulating or pumping the water from the storage tank to the collector. Then from the collector, so here you can see the difference. The storage tank is placed at the bottom. So if you are not able to place the storage tank at a level higher than that of the collector, so what you can do? You may have to use a pump to maintain the circulation. You have to pump the cold water from the tank to the collector. If the tank is on the top of the collector, by gravity it will flow. But here, in this case, direct circulation system, it is not possible. It is also known as active solar water heater system. Active. The other one is passive. So here it is active. There is a mechanical device to maintain the circulation. I hope it is clear the difference between direct circulation system and thermosiphon. Third classification of solar water heater is drain down systems. These are generally indirect water heater systems. Previous one was direct water heating system. This is indirect water heating system. Treated or untreated water, that is not applicable for us. It is circulated through a closed loop and heat is transferred to potable water through a heat exchanger. So there will be a heat exchanger. I'll show you the diagram. So when no solar heat is available, the collector fluid is drained by gravity to avoid freezing. So that's why it is the name drain down system. So whenever there is no solar energy available during the night time, the collector fluid inside the collector will be drained down. You can see here, there is a storage tank, there is a collector, and the connections, air vent valve, etc. And again you can see a pump here. Again there is a pump. Okay, so pump will be maintaining the circulation to the collector from the storage tank, and the only extra fitting is the drain out valve. Whenever there is no, again this drain down system is also applicable to cold countries where the nighttime temperature is very low. Okay. The fourth category is indirect water heating system. Freeze protected fluid is circulated through a closed loop. Again, there is a closed loop, and its heat is transferred to potable water through a heat exchanger with 80 to 90% efficiency. So in the previous system also, the storage tank could be replaced by a heat exchanger. So this is a heat exchanger. The storage tank could be a heat exchanger where the closed loop antifreeze fluid, always antifreeze fluid, will be utilized to circulate in the collector system that will be exchanging heat to the actual fluid, that is water, in the heat exchanger in this storage tank. Clear? So indirect water heating systems, so the closed loop will be through the circulating through the collector or the evacuated tube, whatever it is. The heat is transferred to potable water through the heat exchanger with 80 to 90% efficiency. So most commonly used fluids for freeze protection are water ethylene glycol and water propylene glycol solutions. We can see here. This is similar to the previous one. So only the difference of the drain down system and indirect heating system is, in the drain down system there will be separate provision to drain down whenever there is no solar energy available. There will be provision to drain down the working fluid so that freezing is avoided. So in the closed loop, you can see here the closed loop is this blue and red line that forms a closed loop in the heat exchanger. Now in this heat exchanger, you can see there will be some water or whatever you need to heat. So domestic hot water, domestic cold water also obtained from the bottom, and domestic hot water is obtained from the top. So this is an insulated storage tank. So there is a closed loop in which separate fluid, there will be two different fluids. One fluid, antifreeze fluid, specifically meant for the hot this thermal collector, and the other one will be the working fluid which is directly used for domestic applications. I hope it is clear. So this is the working. Rather than using a heat exchanger that is separate from the solar fly plate collector, indirect hot water systems use pumps to circulate the heat transfer fluid liquid around the closed loop. You can see the pump here, from the collector to the heat exchanger. A copper coil in the storage tank or a flat plate exchanger outside the plate collects the heat from the heat transfer antifreeze solution to heat up the water in the tank. This transfer liquid antifreeze solution, in which indirectly heats the water, permits year-round operation when temperatures drop below freezing also. The nature of closed loop system as such allows for an easy conversion to solar heating with an addition of a flat plate and the ability for an easy installation, location, feasibility. The last one is air systems. In this indirect system, the collectors heat the air which is moved by a fan through an air to water heat exchanger. So instead of using water or any other liquid in the flat plate collectors, air is used as the working medium in the collector. Then the heat absorbed by the air will be transferred to water in an air to water heat exchanger. The efficiency is comparatively low when compared to the other systems. It is 50% only. You can see here there will be a collector, there is a heat exchanger, air to water heat exchanger, then there is a separate water heater. So these are the different types of solar water heater systems. I hope it was informative and well explained. If you have any doubts, please revert in the group or through messages. You can read a lot of articles in these topics. It is available throughout the internet. If you have any doubts,